discuss some properties of definite integrals. These are going to make your life a lot easier. Suppose I have two situations, and these are incredibly easy to evaluate. Suppose the upper and lower integrand are the same. So if f is defined at a, and the integral from a to a of f of x dx is 0. So basically this means no matter what our curve is, alright, the area beneath a point is 0. Similarly, we define the area from b to a of f of x dx is minus the area from a to b of f of x dx. So if the area from a to b is positive, the area from b to a is negative. Now, let's evaluate a couple of definite integrals. The integral from pi to pi is sine. Now, we don't know how to integrate sine just yet, but we know that's 0 because the upper and lower integrands are the same. Now, for this one, I'm going to tell you that the integral from 0 to 3 of x dx is 9/2. And I'm going to tell you the integral from 0 to 3 of 2 dx is 6. So, that tells me that the integral from 0 to 3 of x dx plus 2 dx, 0 to 3, is 9/2 plus 6. So that's 9/2 plus 12/2, so it's 21/2. So what that tells me is the integral from 3 to 0 of 2x plus 1 is negative 21/2. Now I've given you these numbers, all right? You are not supposed to know how to do this yet. So try these notebook problems, stop the tape, and when you're done, come back because we got some more cool stuff to do. Now let's look at the additive property. The integral from a to b of f of x, all right, and a and b can be anywhere on your integral. Anywhere on your integral. So if I want to integrate from a to b of my interval, then the integral from a to any point c plus the integral from c to b is the same thing as integrating from a to b. So I can go from a to c and add that to the integral from c to b. And that's the same as the integral from a to b. So what if I were to look at this and I could tell you that on negative absolute value of x is equal to minus x on the interval x is -1 less than 0, and it's equal to x when x is positive. Now, we don't know how to figure this out just yet, but we do know triangles, don't we? So for each of these, the base is 1, the height is 1. So I can rewrite this as the integral from -1 to 1 of negative x dx plus, to 0, plus the integral from 0 to 1 of x dx. Now, I don't know how to do this integration just yet, but I know that this is the area of a triangle. Okay, and they're the same triangle, so it's going to be twice the area of the triangle. So it's going to be twice base times height. So it's 2 times 1 times 1, so it's 2. You're done. Now, when you know how to do these integrals, you will plug them in. You won't do this stuff. Now, let's talk about another property. Suppose I multiply by a constant k. In this case, this function is f of x here is x, and this is 2x. So these are the two lines. So pretty much the integral from a to b of kx dx is the same as if I just pull this k out, and it's the integral of f of x dx. So if I find this area and I double it, that'll give me the area of the whole thing. What if I add functions? Well, this function, the green function, is sine of theta, or sine of x, while g of x is cosine of x. So the blue one, let me switch over here to blue, f of g plus f of x plus g of x is in blue. Now, I'm going to have trouble doing more complicated trig functions, but I will be able to find f of x plus g of x, or f of x and g of x, and then add those two together. So basically, you can break these up. Now, let's look at how we're going to use these. Get it in. All right. Suppose I tell you that the integral from 1 to 3 of minus x squared dx is 26/3. Suppose I tell you that the integral from 1 to 3 of x dx is 4, and I tell you that the integral from 1 to 3 of dx is 2. All right, so how am I going to do this problem right here? Well, I know this is, I need a negative sign there, I made a mistake, happens. This is going to be the integral from 1 to 3 of minus x squared dx plus the integral from 1 to 3 of 4x dx plus the integral from 1 to 3 of minus x dx. All right, so I can factor out a negative 1 here, and this is the integral from 1 to 3 of x squared dx. Actually, I should have left it like that because that's how I defined it. Plus 4 times the integral from 1 to 3 of x dx plus negative 1 times the integral from 1 to 3 of dx. Let me go ahead and leave this in here. So I know the integral from 1 to 3 of x squared dx is negative 26/3. And I know the integral from 1 to 3 of x is 4, so this is going to be 4 times 4. This is plus negative 1 times the integral from 1 to 3 of x dx is 2. So we wind up with minus 26/3 plus 16 minus 2. Now, you can just go on and finish down the algebra here. Oh, sorry about that. Well, you can do that. Go ahead and do these notebook problems. Stop the tape. Turn it back on when you're done. We have just a little bit more to do. Now, inequalities are also preserved when we do integration. If f is integrable and positive, then the integral is going to be positive. So the area under that curve is always going to be positive. It doesn't matter what the function looks like. Now, if f and g, now in this case my f is this red function, my g of x is a green function. Suppose f and g are integrable, and f of x is always less than or equal to g of x. Then the integral, or the area under f of x, has to be less than or equal to the area under g of x. That makes sense when we're looking at a graph. Now, one more here. If f is integrable and non-negative, this is very important. It doesn't mean it's never 0. It just means it's never negative. So if f is integrable and non-negative on this interval, and it doesn't matter where this interval is, then that integral is going to be positive or non-negative. And finally, inequalities are preserved. Suppose I have the function y equals x squared and y equals x. F and g are both integrable on our closed interval. Now, this one's kind of interesting because if I were to integrate from 0 to 1, I see x squared is always from 0 to 1, x squared is less than x. While from 1 to 2, x squared is greater than x. So if I were to integrate from 0 to 1, x squared dx, that's going to be less than or equal to the integral from 0 to 1 of just x. Conversely, if I were to integrate from 1 to 2, x is less than x squared. So we get this inequality. Now let me ask you, can we make any statement about the integral from 0 to 2 of these two functions? Okay, can we say one is greater than or equal to the other? Are they? And the answer is no. You can't. We don't have the ability to solve this right here, so we're not going to try. Because in part of this interval, x squared is less than x, and in another part, x squared is greater than x. All right, turn off the tape, finish your homework. Have a great evening.